So in the last lesson, we learned to graph inequalities. Now we're going to combine that with solving equations, and we're going to solve and graph inequalities. All right, so we're going to solve these equations using the method we learned. If it's add 19, you subtract 19 from both sides. Borrowing, and x equals 17. If it's subtract 1.7, you add 1.7 to both sides. And you get 10. Now, it's 10.0 there. I'm going to erase the 0.0 because that's not helpful. It's 10 equals x. X is being multiplied by 6. You divide both. Notice I'm right. That's how I write division in algebra. We divide both sides. And yes, this is the beginnings of algebra. So we're dividing. Now here, I think some of you could do it in your head, but if you do side work, put the negative there so you don't forget it. 6 into 12 goes twice. Oops. Remainder, bring down the 6. Oh, it goes in 21. So the answer is x is negative 21. The solution, by the way, this answer is called the solution. And we have been solving equations. We evaluate expressions, or we simplify them. Right? We both evaluated and simplified expressions. Now we're doing something different. We're solving equations. X is being divided by 8, so we're going to multiply both sides by 8. And 5 times 8 is 40, 4 times 8 is 32, plus 2 is 36, and then so it's 36.0, but we're going to write 36. Okay, so now we're going to solve inequalities. It's the same thing as long as you've been doing it the way you've been shown. If it's subtract 2.37 or 2 and 37 hundredths, you add 2 and 37 hundredths to both sides. You're going to keep that symbol, whatever it is, the same. And that is 3.97 is greater than whatever x is, and we'll talk about that as well. All right, so we're solving inequalities. It's the same process. So if it subtracts 17, right, we're trying to get x by itself. Same process. So if it subtracts 17, you add 17 because x minus 17 plus 17 is x. You bring this symbol right down. You do not mess with it. You leave it exactly the way it is. Don't write an equal sign either. Then you add 17 to the other side because the properties of equality, since we haven't said that in a couple of days, properties of equality say that if you do something to one side of an equation, you also do it to the other side. Now, there's a glitch in the properties of equality for inequalities. We're going to get to that. But the properties of equality say you do things to both sides. So 12. And so what does that answer say? It says all the numbers that make that true are less than or equal to 82. And let's write that. All the numbers are less than or equal to 82. Now, right, 82 makes it true, but so does any number smaller than 82 makes that true. So how many answers are there? Don't say one. There's an infinite amount of numbers that will make that true. That's the solution. Okay, so what's going on here? You subtract 8, you add 8 to both sides. 16 plus 8, and so you bring this straight down, and 24 is less than x. Now, it's perfectly fine to leave it that way. There is going to be times when you want to switch that around, and we'll talk about that. But there's nothing special about sides. But sometimes 24 is less than x is harder to interpret than this is also the same as x is greater than 24, right? If 24 is less than all the numbers, then all the numbers are greater than 24. That is the same thing, but you do not need to switch it around unless we're going to do something else with it. All right, so we're going to solve the inequality and graph the solution, combining everything. So it's add 9.5, so you subtract 9.5 from both sides. You bring this symbol straight down, x is greater, there's a 0, x is greater than 4. All the numbers are greater than 4. 1, 2, 3, 4. 4.0 is not better than 4. Open circle, because not 4, but all the numbers greater than 4. So you solved it, and then you graph it. You solved the inequality, and you graph the solution. So let's do some more. We're going to, subtract x is being multiplied by 12. You divide by 12. Right? So here maybe some side work is required. 12 into 20 goes once. Bring down the 4. 12 and 84. 7. So x is less than or equal to 17. X is being divided by 5, so we're multiplying both sides by 5. We're going to leave x the way it is. 5 times 4 is 20. 70 is greater than or equal to x. All right, divide both sides by 5. X is less than or equal to negative 6. So we have to show negative 0. Then what? Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Close circle on negative 6 because we have the or equal to symbol. And we need the numbers less than or equal to negative 6. They're this way. We solved it and graphed it. Okay, so here's the glitch in the properties of equality. If you multiply or divide both sides of an inequality by a negative, you have to flip the symbol around, and let's see that. So in one of these, you flip the symbol around and not the other. So let's see that. So what's the procedure? In this one on the left, x is being multiplied by negative 2. You have to divide both sides by negative 2. You cross that out, and you get a negative 3 here. Over here, x is being multiplied by 2. You divide both sides by 2, and you get a negative 3 here. Now, the key is, what did you do? In this one, you divided both sides by a negative. And when you do that, you have to flip the symbol around. The answer is x is greater than negative 3. If you do the one on the right, you just leave it, right? We did not, there was a negative in the problem, but that doesn't cause this. It's when you multiply both sides by a negative. And just briefly, right? So negative 5 is greater than negative 8, right? So if, yeah, let's do negative 100, right? Negative 5 is way bigger than negative 8, right? Negative 1,000,000 is very small. So if I say divide both sides by negative 5, this one, right? You don't need an x to do things to both sides. This side becomes 1. This side, negative 5 goes into 100, positive 20. If you leave the symbol, now you're saying 1 is greater than 20. No. When you divide both sides by a negative, it causes this symbol, if you want to keep your inequality true, you got to flip the symbol around, right? Because 1 is less than 20. And that's not just for that case. That's always true when you divide both sides by a negative. So this is one of the trickiest things in math, because you're doing all this work, and you get to the end, and I got to remember to flip the symbol, because I did this. So let's practice. So one of those you flip the symbol, one you don't. So the one on the left here, I'm multiplying both sides by negative 4. So the negative 4 is crossed out. X divided by negative 4 times negative 4 is x. Negative 4 times negative 5 is positive 20. Same over here, I'm multiplying both sides by positive 4. And, hold on. I wasn't consistent, so I'm not going to be consistent. Sorry, I was thinking about something. But multiply both sides by 4, and you get negative 20. But in this one, we just multiplied by 4. That's fine. All the numbers that are solutions are greater than or equal to negative 20. But over here, we multiplied both sides by a negative, just like we divided both sides by a negative. You have to flip the symbol around to get the correct answer. The answers that will make that true are less than or equal to positive 20. Now, adding and subtracting a negative does not do this flipping. It is only multiplying or dividing by a negative, right? So let's practice. So one of the things is, I want you to look at these. One of them, of the 4, you have to flip the symbol around. Do you know which one it is before we even start? So we're going to add 68 to both sides. X, right, we're adding and subtracting are never a problem for flipping. And x is greater than 227. Here you're subtracting 1 3/10 from both sides. We're lining up our decimal points. And so we have to do a little borrowing here. There's a 7, and then it's going to be 5. So I lined up my decimal points, and I'm getting 15.7 is less than or equal to x. Here I divide both sides by a -4. And that crosses out. 44 divided by 4 is -11, but I just did that. This is the one where the symbol gets flipped. And lastly, here we're multiplying by 6. X is greater than -54. No need to flip the symbol because we multiplied both sides by a +6. Here we're multiplying both sides by -2. We get x, 2 times 5. This is going to be negative on here, over here. And 2 times 5 is 10. Carry the 1. 2 times 3 is 6 plus 1 is 7. So there I got -7 over there. But did I just multiply both sides by negative? Yes, I do. The answer is x is greater than or equal to -7. I flipped this. And so we're going to put -1, -2, -3, -4, -5, -6, oops, -7. I got to go one more. I got to put a closed circle, and I need the numbers bigger, greater than or equal to -7, right? Flipped because of the negative you multiplied both sides by. Good luck on the homework.